what is irrigation. We will study about Indus Basin irrigation system, what are the different irrigation types and methods of water application to the farms. Now, what is irrigation? Irrigation may be defined as the science of artificial application of water to the land in accordance with the crop requirements throughout the crop period for full-fledged nourishment of the crops. So what is irrigation? It is the science of artificial application of water to the land. So as I said before, that the natural way to supply water to the crops is rainfall. So if we have rainfall that can supply correct amount of water to the crops at the required times, then there should not be any need of artificial application of water. As you already know that rainfall, it is a random variable, means that sometimes we have more rainfall, sometimes we have less rainfall, and also rainfall cannot ensure the required quantity of water to the crops. And not only at one place, but at all the places where we grow the crops. So since it is very difficult, that's why we have to artificially supply the water to the crops. Because agriculture provides the food to the population, so this is important for the survival. So that is why we have this irrigation, that it is the science of artificial application of water to the land in accordance with the crop requirements. How much water the crop require, according to that we have to supply the water throughout the crop period, from the time of sowing the crop to the time of harvesting. So throughout the crop period, the amount of water that is required by the crop for full-fledged nourishment, so that is known as irrigation. So we artificially supply the water to the crops during the crop period according to the crop requirements. This is irrigation. Irrigation is the art of supplying water to the land by artificial means to fulfill the water requirements of crops in areas where rainfall is insufficient. Another definition: if rainfall is not sufficient to supply the required quantity of water to the crops and at the required times, because you see that when we feel thirsty we drink water, but if you continue to drink water, that is not beneficial. Same is the case with plants. They require certain quantity of water at different times during the growth. So we have to ensure that quantity of water at the required times. So this is irrigation, that it is the art of supplying water to the land by artificial means to fulfill the water requirements of crops in areas where rainfall is insufficient. Similarly, irrigation may be defined as the process of artificially supplying water to soil for raising crops, or artificial application of water on an agricultural land for the assured growth of plant life. So you can see from all these definitions, we can conclude that it is the artificial application of water to the crops for their full-fledged nourishment. This is known as irrigation. Now, what is irrigation engineering? The science of planning and designing a water supply system to the plants, crops for their normal growth during the period of no rainfall with the help of dam, weir, barrage, reservoir and canal system with headworks, cross drainage works and miscellaneous works of canal like canal falls is called irrigation engineering. So what is irrigation engineering? That it is the science of planning and designing a water supply system. Now we learn that irrigation is the artificial application of water to the crops. So how we provide this water to the crops? For this we have to plan and design a water supply system. That will include construction of a dam, weir or barrage, you see, or we have to directly divert the water from a river through a canal system, or the canals can be provided from the dams with headworks where we can control the flow, and the network of canals if they cross natural streams or drains. So there we have to provide the cross drainage works, that the canal should be taken above the drain, below the drain, that we call as the cross drainage works, and other miscellaneous works like the canal falls, that if there is a drop in elevation of the ground, so how we make the transition smooth by providing canal falls. So all this is known as irrigation engineering. So in simple words, it means we identify the source of water, and then through a network of canals we supply the water to the agricultural land, and all the hydraulic structures that will be required, will be necessary to be provided. So this is known as irrigation engineering, science of planning and designing a water supply system to the agricultural land. Irrigation engineering is the analysis and design of systems that optimally supply the right amount of water to the soil at the right time to meet the needs of the plant system. So it is that the system that we have to design that can help supply the water to the crops. So the analysis and design of that system, this is known as irrigation engineering. Irrigation engineer, an irrigation engineer is the one who helps to bring irrigation water from the source of supply to an agriculture land. So irrigation engineer is a person who will help bring the water from the source to the agricultural land, and will be involved in analysis and design of the system that will supply water from the source to the agricultural land. Now, is irrigation a new science or art that we supply water to the agricultural land? Irrigation system is as old as human civilization. In fact, civilization would probably not be possible without some form of irrigation. The earliest form of irrigation probably involved people carrying buckets of water from wells or rivers to pour on their crops. Now, irrigation means that we artificially supply water to the crops, but the same crops, they provide food, which is important for the survival of human beings. So we are growing crops since the beginning of human civilization. Because food is important for survival, like water, so it means that we have to supply the water to the crops. So since the beginning, today that we have modern system of water application to the crops, in the beginning, those people probably used buckets to carry water from wells or rivers and pour on their crops so that the crops can grow and can provide food for their living. Ancient Rome built structures called aqueducts to carry water from snow melt in the Alps to cities, mountains, to cities and towns in the valleys below. This water was used for drinking, washing, and irrigation. So in ancient Rome, they built aqueducts to carry the water due to the snow melt in the Alps to the cities and towns. And aqueduct, if you remember from hydraulics, so aqueduct is basically a channel that is carried across a depression. And this water was used for drinking, washing, and irrigation purpose. The same water was also supplied for raising the crops. The Chinese are known to have practiced irrigation since 2600 BC. The earliest work in China relate to the development of the delta lands and the Yellow River. The 1130 kilometer long Imperial Canal, also called the Grand Canal, built in 700 AD for irrigation and navigation, is one of the greatest ancient irrigation works. So you can see here that canals were constructed for irrigation and navigation in China long before. Diversion of irrigation works were developed in Iran in about 500 BC. A system of canals, tunnels, tapping groundwater from recharge areas of surrounding mountains and leading it by gravity to the fields to be irrigated is still used in Iran as it was practiced 2500 years ago. So you can see here that these canals, which are very famous even today, that how at that time the people, they through these tunnels take the water to the fields to be irrigated. Diversion of streams by canals for irrigation was practiced in Japan before 600 BC. So you can see here that in Japan, from the streams, canals were divert the water for irrigation. Irrigation by diversion works and direct flooding by rivers is known to have extensively practiced in Thailand, Philippines, and Indonesia. The ruins of Mohenjo-daro and Harappa, these are the Indus Valley civilizations, have also shown the proof of use of water or water supply and irrigation. Clear? Use of water for water supply and irrigation. So you can see here that since the beginning of civilization, water has been artificially supplied to the crops. So irrigation is not a new science. We just improve how to efficiently apply the water to the crops by using the latest technology or latest methods of water application. However, irrigation, it is practiced since long time. Now, irrigation engineering consists of 4 phases. Number 1, storage or diversion. So the first step in irrigation engineering is that we have to store the water by construction of a dam, or we have to divert the water from a river by construction of a barrage. So this is the first phase. The second phase includes conveyance of irrigation water. How we will convey this irrigation water? We have to construct canals for this purpose that will carry the water from the dam or from the river directly. The third phase includes distribution and application of irrigation water. By distribution, we mean that we have to distribute then this water between the different agricultural lands, between the different farmers that own that land. So how we distribute that water, and then how the water is applied to the crops. For this we have different methods of irrigation. Once the water reaches the farm, how it is applied to the crops. And after the water is supplied to the crops, not all of the water that is used by the plants for their growth. So the excess water, for that we have to provide drainage. We have to drain the excess water. because if the water remains in that area for a long time, it will have negative effects on the plants as well as in general. If the water stays, it can become a breeding place for the mosquitoes and it can spread diseases. So when we supply the water to the crops, the water is used by the crops, the remaining water should be drained. So that's why this is important phase of irrigation engineering. So these are the 4 phases of irrigation engineering. In the first phase, storage or diversion, then conveyance of irrigation water through canals, then distribution and application of water to the crops, and the excess water should be drained from that area, for which we have to provide a drainage network. That could include surface or subsurface drainage. So we will study all these 4 phases in detail in this course. Next, we discuss necessity of irrigation. The first important factor is less rainfall, because the rainfall over an area is not sufficient to grow the crops. That necessitates artificial supply of water to the crops. As I said before, if we have sufficient rainfall, then no need of artificial application of water. But as we saw in the first lecture, that the rainfall, it is variable from place to place. Just like you saw that in the Sindh and Balochistan, that areas receive less rainfall during an year that is not sufficient to grow the crops. That's why those areas are classified as semi-arid to arid land. So the reason why we have irrigation is because of less rainfall. The second factor is non-uniformity of rainfall. If we have uniform rainfall over an area, in that case, it can supply water to the crops. But since rainfall is highly variable, this is also one factor that necessitates artificial supply of water, because the rainfall from area to area, this is not uniform. So non-uniformity of rainfall. With irrigation, we can grow commercial crops that require additional water. Now, by commercial crops, we mean that the crops that we sell, for example, cotton. So that is a commercial crop that does not provide food, but when we grow cotton, we can sell it and we earn the money. So it means that we can grow commercial crops with additional water that will be supplied by irrigation. In irrigation, we can have controlled water supply. you can see that over the rainfall we have no control. Rainfall is a natural process and it occurs depend on the natural conditions of that area. But when we artificially supply water to the crops, so we have control over the water supply. For example, from the dam, you can stop the supply of water in the canals. Or if we have diversion of water from a river, we can stop the water. Or we can control the quantity of water that is flowing. So this is the advantage that we have controlled water supply. Development of agriculture in desert area. So you can see that in deserts we can bring the land under cultivation if we can construct canals that can supply the water from dams or from rivers to that area. So it can be brought under agriculture. We can grow crops. So this is possible through this irrigation. So these are the different factors that necessitate irrigation and irrigation engineering. Now, advantages of irrigation: increase in food production. Because of irrigation, more area is brought under cultivation. We are able to grow more food to feed the population, and also agriculture is the backbone of our economy. It provides job for millions of people. So you can see here that the first factor is increase in food production. So because of irrigation, that we artificially supply the water to the crops at the required times and required quantity, so we are able to increase the food production. Cultivation of cash crops. Cash crops mean that can provide cash, money. Just like as I said, we have cotton. Cash crop can also be tobacco, although it is not encouraged anymore. But these are an examples of cash crops that can lend the farmer cash. So this is an advantage of irrigation, cultivation of cash crops. Generation of hydroelectric power. Because we construct the dam to store the water that can be supplied for irrigation, but we are also able to generate the electricity. Similarly, hydroelectric power can be generated. You see the Ghazi Barota hydropower project. It is just a canal which carries the water from Ghazi to Barota, but there a head is available, and we have installed 5 Francis turbine and generating electricity. So because of irrigation, we get the opportunity to generate hydroelectric power. Domestic and industrial water supply. The network of canals which supply water to the crops, the same canals can be used to supply water for domestic and industrial purposes also. Because the crops, they does not require 24 hours the water every day. So we supply the water to the crops when they require. So during the remaining period, the same canals can supply water for domestic and industrial purposes to the adjoining areas. Improvement in the groundwater storage. So you see, we construct network of canals that supply water for agriculture. The same canals, seepage takes place, the water infiltrates into the soil, and these water can recharge the groundwater. So improvement in the groundwater storage. Also the dams that we construct, they store the water, and then from the reservoir bed the seepage takes place, and the same water they recharge the groundwater storages. So this is an advantage of irrigation. Improvements of communication. So you can see here that when we construct canals, along the sides of canal we also built roads. So because of irrigation, we have improvements of communication. So these are the advantages of irrigation. Now some disadvantages. Raising of water table, that is water logging. Because of irrigation that we supply artificially water, so on the other side you see that the dams that we construct, the seepage takes place, and the water table in the adjoining areas can raise, and if the water is raised to the root zone, then what will happen, that plants will not be able to grow. So the productivity of the land, that is adversely affected. Because of irrigation, you see that the area, if it is flooded and the water is not drained, this can also happen. That is why I said that drainage is important and prerequisite actually of irrigation engineering, that we have to drain the excess water from that land. So if in an area the water table intersects the ground surface, you will see that the water will be there in the root zone all the time. That is not beneficial. We cannot grow crops. So that is known as water logging. Because of irrigation, this is the disadvantage, that the water table can raise to the root zone or the surface of the ground, and the land can become not productive for agriculture. So this is a disadvantage of irrigation. You can see here that if the water stays over the land in this fashion, we cannot grow crops. This area, this is known as waterlogged. This is waterlogging. So it means that, for example, when we supply the water to the crops use the water, and then the excess water has to be drained from that area. Otherwise, productivity of the land that will be affected. The second thing is we have damp climate, which is undesirable. Because it can become breeding place for mosquitoes. And it will result in spreading of diseases in that area. So the disadvantages are that we artificially supply water to the crops. We should ensure that we supply that quantity of water that is needed by the crops during the crop period. Excess than that, then there will be negative impacts. This is what is written here. Now, other problems that are associated: competition for surface water rights. It means that the water which is used for irrigation may not be used for other purposes such as domestic and industrial water supply. So there could be competition. It means that we cannot supply water for agriculture unlimited. There are other competitions. For that, we have to supply water that is available in an area for drinking purposes, for domestic water supply, for industrial purposes, and for agriculture purposes. So it means that the water which is supplied to the crops, the same water will not be then available for domestic or industrial water supply. So it means that competition for surface water rights. Depletion of underground aquifers. If we are using the groundwater by pumping for irrigation purposes, this is what is happening in Punjab. It will result in depletion of underground aquifers. So it means that when we pump the groundwater, it should be that it does not cause negative impact on the groundwater storages. The groundwater that is recharged by rainfall or other sources that we studied in the first lecture, that is seepage from the rivers or from the canal network, and then we are extracting that groundwater. So if the extraction is more than the recharge of the groundwater storages, then definitely it will result in depletion of these underground storages. And this is important source of water for domestic, industrial, and agriculture purposes. You can see here in Peshawar we are using the groundwater for different purposes. So if the groundwater storages finish, then you can imagine. So the problem with irrigation is that extensively we are supplying the water to the agriculture, that cause depletion of underground aquifers. Build-up of toxic salts on soil surface in areas of high evaporation. In an area when we supply the water, so the water, it dissolves the different salts that are present on the surface of the earth. So in areas where there is high evaporation rate, the water quickly evaporates and leaves behind these salts. So when these continues, what happens is built up of toxic salts on soil surface. So it means that because of high evaporation, the water evaporates, leaving behind these salts, and it will negatively affect the growth of crops. Land productivity, that will be negatively affected. Over irrigation, because of poor distribution, uniformity or management of waste water, chemicals, and it may lead to water pollution. It means here that when we supply more water that is required by the plants, and this is happening actually in Pakistan, that we are supplying more water at a time that is required by the crops. This is because of the poor distribution. So what can happen is that we supply pesticide fertilizers. So those chemicals are mixed in water or mixes with water when water is supplied to the crops. So the same water, after drainage, surface drainage either joins the river, so can cause pollution, or if it infiltrates into the soil and then reaches the groundwater, carries along these chemicals, can pollute the groundwater. So the groundwater will not be then fit for drinking purposes, for example, or other uses. This is actually the problem that we are facing in Punjab. So these are the problems associated with irrigation. Now, aerial distribution of rainfall in Pakistan. You can see here that 67% of land in Pakistan receives on average 10 inches rainfall annually. So that areas are classified as arid zones. Average annual rainfall is 10 inches. 67% of the land. Another 24% of the land, the average annual rainfall varies from 10 to 20 inches. That is classified as semi-arid. So you can see here that 91%, according to this source here, 91% of the land of Pakistan, that is semi-arid to arid. It means that less rainfall is obtained, that is not sufficient to grow crops. You can see here. That is why Pakistan has the largest surface irrigation system in the world. We have the Indus River and its tributary, and then the different dams that we have constructed, barrages that supply water for agriculture purposes. Pakistan is an agricultural country. Agriculture is the backbone of our economy. So you can see here the importance of irrigation and irrigation engineering. .5% land of Pakistan that is humid, 20 to 30 inches average annual rainfall, and very wet para-humid, that is 3.5% of land. Average annual rainfall is 30 inches. So you can see here that in Pakistan, large portion is semi-arid to arid, which receives less rainfall, that is not sufficient to fully grow the crops. We have to artificially supply the water for full growth of crops that provide food for our population. So that is why we study this irrigation engineering. Next, we discuss about the Indus River basin. So you can see here that this boundary shown by a red line here, this is actually the Indus River basin. It means that all of the rainfall that occurs within this area, that will contribute water to the outlet here. You can see here, this is the outlet here. The same concept of catchment or basin that you studied in your hydrology course. Wherever the rainfall occurs within this boundary, that will contribute water to this outlet here. So this is the Indus River basin. You can see here the different rivers which are shown. For example, you see the Gilgit River, then the Indus River that originates here, and then it flows. You see the Kabul River, the Swat River, it joins the Indus River. This is the Indus River here. And then we have the Jhelum River. This is the Jhelum River here. We have Chenab River here. We have the Ravi River, the Beas River, but it joins the Sutlej River. This is the Sutlej River, which originates here, and then the Sutlej River, it flows into Pakistan. You see that all these rivers, they join here, the Indus River, and the Indus River, it continues. See, this is the Indus River, and it drains into the Arabian Sea. So based on which this is known as the Indus River basin. You can see here that the Indus River basin, greater portion occurs in Pakistan, but you see here Kabul. It means some portion of the Indus River basin also lies in Afghanistan, in China. Clear, this is the Chinese territory. And you see here that this is also covers some portion of India. So actually the Indus River, it is Indus River basin covers the 4 countries. So this is the Indus River basin, based on which we discuss the Indus River and its tributaries. And in Pakistan we have the Indus Basin Irrigation System. Now the hydraulic structures in the Indus Basin Irrigation System, you can see here that we have these 6 rivers, the Indus, Jhelum, Chenab. So these are the western rivers, and as per the Indus Water Treaty, Pakistan has full control over these 3 western rivers. It means Pakistan can fully utilize these 3 rivers. But remember, the origin is in India. Indus, Jhelum and Chenab. If I go back here, you see this Indus. So this is originated here. This is Jammu and Kashmir. It's not that these are not originating in India. Similarly, you can see here the Jhelum and the Chenab here. You see the Chenab here. So these are also coming from India. But under Indus Water Treaty, Pakistan has full control over the use of water of the 3 western rivers, whereas India has control on the use of water over the 3 eastern rivers. That include the Ravi River, Beas and Sutlej. So on the Indian side, you see this red line shows the partition. They have constructed hydraulic structures. You can see here on the Pakistan side, we have this Tarbela Dam, Kalabagh Barrage, Mangla Dam on the Jhelum River, Marala Barrage, Kadirabad Barrage on Chenab, then Rasool Barrage on Jhelum River. You can see here Chashma Barrage, Tonsa Barrage on the Indus River, then Trimu Barrage here, Sidnai Barrage, Baloki Barrage here on River Ravi. Then we have Suleiman Ki Barrage here, this one, Islam Barrage, clear on the Sutlej, then Panjnath Barrage and Gaddu Barrage here. So these are the different hydraulic structures that exist in the Indus Basin Irrigation System. Now you can see here this Indus Basin Irrigation System that we talk about in Pakistan. You see here the rivers that flow through Pakistan here, Indus River and its tributaries. So you can see that along these rivers, on the banks of these rivers, you see that we have these agriculture areas. You can read this paper in detail the source which I have provided here. So for example, you see that we have this yellow area here. So this is Punjab mixed cropping. Different crops that are grown over this area. Similarly, here the light blue color which you see here, this area. So this is Punjab sugarcane wheat. Then this light blue area here. So this is Punjab rice wheat. Then the dark green here, this area which continues here. This is Punjab cotton and wheat. You see the purple color here in Sindh. So Sindh cotton, wheat. Then the dark yellow color here which you can see, Sindh rice and wheat. Similarly in KPK here, the area which you see, the dark blue color, northwest mixed cropping, the different crops which are grown here. So you can see here that because of this Indus Basin irrigation system, that we are diverting the water from these rivers to grow the crops in these areas. Now, land use in Pakistan. So the total geographical area, that is 196 million acres. In Pakistan, area suitable for agriculture, that is 77.1 million acre area that is suitable for agriculture. The cultivated area, that is irrigated plus the rain-fed Barani, that is 54.5 million acres. Now area under irrigation by all sources, that is 44.5 million acres. Additional area that can be brought under irrigated agriculture, that is 22.6 million acres. So you can see in this figure here that area under irrigation, that is shown by this shaded blue or green color here. So that is area under irrigation. Now this white blue combination is an area that can be brought under irrigation. You see the potential of more lands that can be developed for agriculture purposes. And you see here this shaded area here, that is deserts. So you can see that there exists great potential, that areas that can be cultivated that will result into food Pakistan can become self-sufficient in the food, and also we can export and earn foreign exchange. This shows the importance of irrigation engineering in Pakistan. Now this Indus Basin irrigation system, Pakistan's Indus Basin irrigation system is the largest contiguous gravity flow irrigation system that serves the Indus River and its tributaries, namely the Jhelum, Chenab, Ravi, and Sutlej rivers. This Indus Basin irrigation system, this is the largest continuous means mulhik, gravity flow irrigation system that serves the Indus River and its tributaries. So this is the largest continuous surface water irrigation system in the world, that starts from the north to the south of the country. It consists of 3 major storage reservoirs, 19 barrages, 2 headworks, 2 siphons across major rivers, 12 link canals. As I said before in the first lecture, link canal means that link the 2 rivers. You want to divert water from one river to another river, that is done by these canals. These are known as link canal. 44 independent canal commands, 23 in Punjab, 14 in Sindh, 5 in KPK, 2 in Balochistan, and more than 107,000 main water courses commanding an irrigated area of 16 million hectares. So this is the different canals that we have, link canals, the independent canals that we have, network spread in all the 4 provinces, the headworks, the barrages, in this Indus Basin irrigation system. The aggregate length of canals is about 56,073 kilometers. This is the total aggregate length. The canals that we have provided in the Indus Basin irrigation system, if you just add up their length, that is 56,073 kilometers. In addition, the water courses, farm channels, and field ditches are estimated cover a length of about 1.6 million kilometers. So we have the main canals and then the water courses, farm channel, field ditches, narrow channels that supply water. So that cover a length of about 1.6 million kilometers. The irrigation system of Pakistan further utilizes over 41.6 million acre feet of groundwater pumped through more than 700,000 public and private tube wells. So in addition to the surface water that we are utilizing from the rivers, Indus River and its tributaries, in Pakistan we are also utilizing 41.6 or more than 41.6 million acre feet of groundwater that is pumped through more than 700,000 public and private tube wells. This is for agriculture purposes. Clear? The irrigation system of Pakistan further utilizes over 41.6 million acre feet of groundwater pumped through more than 700,000 public and private tube wells. So this is in the context of irrigation system, remember. The total geographical area of Pakistan is 709 million hectares. Out of this, only 34 million hectare area is suitable for agriculture production, while only 20.1 million hectare area is practically cultivated. So 34 million hectare is suitable, only 20.1 million hectare area is practically cultivated. The irrigated area in all the 4 provinces is estimated as 16 million hectares. The remaining cultivated area is rain-fed, that is dependent on the rain. So you can see here that the irrigated area in all the 4 provinces is estimated as 16 million hectares. The Indus Basin river system makes a prime source of water for Pakistan's agriculture, which provides for an income source to about 75% of the country's population and contributes about 25% to the GDP, gross domestic product of the country. 25% to the GDP, that is contributed by this Indus Basin river system. It engages about 45% of the country's labor force and provides a sound base for the economy in terms of export and foreign exchange earnings. So all these figures which are provided here and in the previous slide, these are from this source, Applied Irrigation Engineering. That is a book published from the University of Agriculture in Faisalabad in 2017. Next, we start with discussion on water budget of Pakistan. So this is the water budget, overall water budget of Pakistan. This figure is taken from the book Irrigation and Hydraulic Structures by Dr. Iqbal Ali. So you can see here the river Indus, 90 million acre feet of water it is contributing. River Jahlam, that is 21 million acre feet. River Chenab, 22 million acre feet, and other tributaries we can say that is 4.5 million acre feet, making a total of 137.5 million acre feet. Now this 137.5 million acre feet that is contributing to Kharif season, that is 111, and to Rabi season, that is 22 million acre feet. Now you can see that out of this 32 million acre feet, that is discharged into Arabian Sea. This much water that is wasted, that is discharged into the Arabian Sea. Now the water that is available during the Rabi season and the Kharif season, so the Kharif canal flow, that is 64 million acre feet, and the water that is stored 15 million acre feet, we have dams, reservoirs. So the storage, that is 15. Now you can see that this water which is available, this surface water, so we have evaporation, the water that evaporates from the rivers, 4.5 million acre feet that is evaporated directly from the rivers. Now the water which flows during the Rabi and Kharif seasons, so evaporation from the canals, that is 7.5 million acre feet. And the water courses, that is 7 million acre feet. We are supplying 38.1 million acre feet to well discharge. So again, there will be evaporation, that is 5.6 million acre feet. So this is the evaporation from the water that is coming in different sources. From the same rivers and canal network, we have seepage of water. That water infiltrates, and then the same water, it joins the groundwater reservoir. This is the groundwater reservoir you can see here. So the rivers and the rains, they contribute 7.1 million acre feet. That directly recharges the groundwater reservoir. Then the water is flowing in the canals. So from the canals we have seepage, irrigation canals, that is 15.3 million acre feet. Then the link canals which link the two rivers, 3.0 million acre feet. From the water courses, another 7.5 million acre feet seepage takes place that recharges the groundwater reservoir. And we have discharge from the groundwater through tube well that supply water, well contribution, that is 32.5, that coming to the agriculture fields where we have crops. From the Rabi flow, 22.4 million acre feet water is supplied to the agriculture lands. And from Kharif flow, 38.4 million acre feet. And also we have rainfall in Pakistan, so it contributes 6 million acre feet. From the fields, we have runoff, that is, you see drainage, not all of the water that is used by the crops. So that is estimated as 6 million acre feet. And the water infiltrates into the soil, root zone used by the plants, and further percolation. You see that from the fields, 12 million acre feet of water that recharges the groundwater. So this is the water budget of Pakistan. The values can slightly vary, but this is how the water budget of Pakistan looks like. This is from the book by Dr. Iqbal Ali. Now, water budget of the Indus Basin irrigation system, this is taken from internet. You see that mean annual river flows, that is between 140 to 150 million acre feet. Mean annual canal diversions 103 million acre feet. Canal supplies at water courses had 77 million acre feet. And canal supplies at the farm gate that is available to the farmer 54 million acre feet. Because we already discussed the seepage losses, the evaporation losses, and the groundwater contribution around 50 million acre feet. So the irrigation water at the farm gate, that is 104 million acre feet. So you can see that agriculture GDP, that is $15 billion, $500 million per million acre feet. Now, water budget of the Punjab irrigation system. So you can see here that Punjab share in water accord 1991 56 million acre feet. Canal diversions 50 million acre feet. Losses in the canals, that accounts 13 million acre feet. So we have water availability at the outlets, at Moga. At the outlets, that is 37 million acre feet. We have losses in water courses, around 11 million acre feet. Water available at the farm gate, that is 26 million acre feet. Now the groundwater abstraction, that is 33 million acre feet. Field losses, that is 21 million acre feet. So total available water at field level, that is 59 million acre feet. The rainfall contribution, that is 7 million acre feet. This is for Punjab. A net water available at the field level, that is 38 million acre feet. Now you can see that the water that is available for crop use, that is 45 million acre feet. But the actual crop water requirements, that is around 65 million acre feet. You can see here that the actual crop water requirements are 65 million acre feet, but the available water is 45 million acre feet. This is the reason that the crop yield per acre in Pakistan, that is lowest as compared to the world. This is the reason here. You can see here why the sustainability of agriculture is not maintained. You see here the gap between the water available and the water required by the crops. This shows we need to improve our irrigation systems so that the losses that occur, you can see here the various losses, if we can minimize these losses, then more water can be available for meeting the crop water requirements. So these are the challenges which are faced by the agriculture in Pakistan. This is the reason that we have the largest irrigation system in the world, but the crop yield is lowest in the world. Now, challenges for Pakistan on the water front: a reduction in water availability. You can see that because of more population, more urbanization takes place. We need more water for drinking purposes, for industrial purposes. We need to grow more food. We need to bring more area under agriculture to meet the food requirements of the country. So this has resulted in a reduction in water availability. The demand of water that has increased. Inadequate storage capacity. You can see that, for example, here I show you that 32 million acre feet of water that is wasted to the Arabian Sea. If we have more storages available, we can store this water and then we can use it effectively to meet the water demands. So we have inadequate storage capacity. Outdated and wasteful irrigation practices. This means that when we supply the water to the crops, we are using outdated methods because that result in waste of the water. You see that in Pakistan we are using the very conventional methods of irrigation. We just flood the irrigated area with water. Not all of the water that is used by the crops at one time. So consequently the water is wasted. If we can use some latest methods, which we will discuss in today's lecture, it can result in saving more water and we can use that water more productively. Unregulated groundwater pumping. We talk about the depletion of groundwater. So the reason is that in Pakistan it is unregulated. The groundwater is extracted to meet the demands, and in Punjab it is used for irrigation purposes. So it should be regulated because this is an important source of water, and if the groundwater storages are depleted, then this source of water will no longer be available for use. So for sustainability, it is important that the groundwater extraction should be less than the recharge, or at best equal to the recharge. So the water that is recharged and the same quantity of water is extracted for use, still it is fine. But if the quantity of water extracted for use is greater than the water that is recharging the groundwater storages, it will result into depletion of the groundwater storages. So we discussed in the first lecture that groundwater is an important source of water supply for different water demands. domestic, industrial, and agriculture water demands. Also, we have the water quality issues in Pakistan. So because you can see that the water which is used after domestic and industrial, that is discharged into the rivers, if it is not properly treated before discharge, will cause pollution. Similarly, the water which is applied for agriculture purposes, it dissolves the fertilizers, pesticides, etc. And then the same water, either through surface drainage, joins the river water or infiltrates into the soil, and through percolation joins the groundwater, will result in pollution. And this is what has happened. And if the same quantity is then used for drinking purposes or other water demand, so it will have negative impacts. Lack of water budgeting and water conservation. So in Pakistan, there is a lack of water budget, that how much quantity of water is used by which sector, so that we can effectively evaluate the water availability and its usage, based on which we can plan for future. And water conservation. Do we have any water conservation schemes? Do we encourage the water consumers to save the water? Inadequate financial resources for water infrastructure and development of water resources. This shows that the water infrastructures that we have, operation and maintenance, development of new water schemes, we have inadequate financial resources for that. Development of water resources means that do we have enough dams in the country that can fulfill one or more purposes. The climate change impacts. In the context of global warming, since we all know that the temperature of the earth is increasing, that is global warming, due to the greenhouse gases, for example, carbon dioxide concentration is increasing, so it traps the solar radiation, because of which the earth heats up, its temperature is increasing. So this phenomena, this is known as global warming. Because of this, the climate change effects which are experienced around the world, so this is also a challenge for Pakistan. Because of this, what is happening, that increase in temperature, what will be its effect on the crop yield? Absence of regional cooperation in management of water resources. As we discussed that the rivers that flow in Pakistan originate in India, although we have the 1960 Indus Water Treaty, but still there are issues on water sharing between the two countries. When we consider the provinces of Pakistan over the sharing of the water, we have the 1991 Water Apportionment Accord, but still there are issues between the four provinces over the use or sharing of the water. This is because of the absence of cooperation. So these are the different challenges for Pakistan on the water front. Now, irrigation system management institutions in Pakistan. Managing institutions at federal level, we have Ministry of Water and Power, Indus River System Authority IRSA, Federal Flood Commission, Planning Commission, Water and Power Development Authority WAPDA. You can see here that at the federal level, these are the institutions that are directly and indirectly involved in the irrigation system management. Managing institutions at provincial level, we have provincial irrigation departments such as Punjab Irrigation Department, Sindh Irrigation Department, KPK Irrigation Department, Balochistan Irrigation Department. Even in KPK we have Minister for Irrigation. So you can see that how much it is important that we have Minister for Irrigation. Provincial irrigation and drainage authorities. So we have Punjab Irrigation and Drainage Authority, Sindh Irrigation and Drainage Authority, KPK Irrigation and Drainage Authority, and Balochistan Irrigation and Drainage Authority. So these departments, they have their own websites which you can visit. They provide information on the completed projects related to irrigation in the respective provinces, the ongoing projects, annual reports, etc. So you can get information about the irrigation system, the projects in respective provinces. Now, average water use for cereal crops, food, ghala, cereal crops. You can see here, food per cubic meter of irrigation water. When you are using 1 cubic meter of water, how much food we are able to generate? You can see here in USA, they are generating 1.56 kg of food by using 1 cubic meter of water. Canada is generating 8.72 kg of food from 1 cubic meter of water. If we talk about the Asia, so you can see here that China is producing 0.82 kg of food per cubic meter of irrigation water. India is producing 0.39 kg of food per cubic meter of water. And you can see here that Pakistan is able to produce 0.13 kg of food per cubic meter of irrigation water. So we talk about that the Indus Basin irrigation system is the largest continuous irrigation system in the world. but you can see here that the crop yield that is lowest in the world. And what is the reason? That we already saw that we have outdated and wasteful irrigation practices. The methods that we are using that result into more wastage of water. If we can use latest methods, latest technology, we can save more water and we can increase the food per unit of irrigation water used. Now we discuss types of irrigation. So irrigation can be divided into surface irrigation, and it can be subsurface irrigation. So in the surface irrigation, the water is supplied over the surface of the ground, and then it is taken up by the roots of the crops for growth. In the subsurface irrigation, below the surface of the earth, through a network of pipes, the water is supplied to the root zone and it is taken up by the plants for growth. So we have surface irrigation and subsurface irrigation. Now surface irrigation, it can be flow irrigation, that is due to the gravity, or it can be lift irrigation, that is the water is lifted by, for example, mechanical means such as the wells and tube wells. So that is lift irrigation. Now flow irrigation, it can be perennial irrigation and it can be flood irrigation, also known as inundation. Now what is the difference between the two? In perennial irrigation, for example, we say perennial river. So it means that throughout the year the water flows in that river. When we say perennial irrigation, it means that throughout the crop period there will be continuous and sufficient quantity of water available for the crops. Means there will be no shortage. So continuous and adequate amount of water is continuously available throughout the crop period. Perennial irrigation. We have flood irrigation. Just like we say that in the river, the water is available only during the floods. When flood came, the water is available. When there are no flood, the rivers, they are dry. So here is also the concept that in flood irrigation, the area is flooded and then the soil moisture in the ground, they supply water to the root zone and that is used by the crops. And in addition to that, the rainwater, that will also supplement this water for the growth of the crops. So this is inundation or flood irrigation. Now, in this case, the water flows due to gravity. In flow irrigation, in lift irrigation, we have to lift the water. For example, wells and tube wells, through pumping, you have to lift the water. And then the water is supplied through canals, through the agriculture fields. This flow irrigation, it can be direct irrigation, that is river canal irrigation. We just divert the water from the river through the canals. or it can be storage irrigation, that is, we construct the reservoir, a storage scheme, and then from there you supply the water, or it can be a combination, storage and diversion. Now, subsurface irrigation, it can be natural subsurface irrigation, leakage water from channels goes underground, may irrigate crops sown on lower lands by capillarity. So although it is not cannot be on a large scale, but sometimes it may be possible that the water leakage which takes place from the channels that carry water goes underground, may irrigate crops that are sown on lower lands by capillarity. So that would be called as natural subsurface irrigation. We have artificial subsurface irrigation, when a system of open jointed drains is artificially laid below the soil to supply water to the crops by capillarity. So in this case, you can see that a network of pipes are provided that directly supply water to the root zone of the crops. So that is artificial subsurface irrigation. Also, an example is Karez in Balochistan. If you have heard, so Karez in Balochistan, that is practiced since long time. So that is artificial subsurface irrigation. Now you can see here that in the subsurface irrigation, we have a network of pipes that run underground and then supply water to the root zone. So you can see here that of course it is expensive. We provide such arrangement in an area. The other disadvantage, not a disadvantage, but challenge would be how to maintain such a system. If there is any blockage that can occur, how we know? So maintenance, that could be an issue. Next, we discuss methods of irrigation water distribution in the farms. So when the water reaches the farms, how the water is distributed through different methods, that we will discuss in this topic. So irrigation water may be applied to the crops by various methods: free flooding, border flooding, check flooding. These are the different methods. Basin flooding, furrow irrigation method, sprinkler irrigation method, drip irrigation method. So these are the different methods by which the water is supplied to the crops. Let us briefly discuss each of these. The choice of irrigation method, how we select. The following criteria should be considered. Water supply available. You see here that some of the methods are very water intensive, supply more water. Some of the methods, they supply less water. So this is one of the factors that will make the choice water supply available. How much water is available? If water availability is scarce, less quantity is available, then we cannot use the flooding methods. We can use the other methods that save the water and only provide the required quantity of water to the crops. So this is important factor, water supply available. Topography of the area to be irrigated. based on topography, which method is suitable to effectively supply the water to the crops, the climate of the area, what crops we have to grow, and then how we supply the water effectively, the soils of that area. This is also important factor. Crops to be grown. What type of crops we are growing? Are these crops require less water or more water? So that will also impact the selection of the particular method. Economics, that the method we supply water to the crops, is it cost effective? For example, if we are using the latest methods, so what will be the cost of installation and then the output that we get in the form of crops? So the economics of that on the selection of method, local traditions and skills. So if we are using some technology, for example, in this case here, the sprinkler irrigation method, so do we have the skills of the farmers that can use this technique of water application to the crops? So these are the different factors that will affect the choice of irrigation method. Now we discuss free flooding. You can see here that we have the main supply ditch, that is the narrow channel that supply water to the farmers. Then we have subsidiary ditches, and the area is flooded with supply of this water. Here we are not controlling the water, that's why it is called free flooding. These are an example. You can see free flooding. In this method, we have main supply ditches that are excavated in the field along the contour or on the slope. Water flows from these ditches to subsidiary ditches and then to the field. Just like you saw here, from the main ditch to the subsidiary ditches and then to the fields. Subsidiary ditches are spaced 20 to 50 meter apart depending upon slope, texture of soil, crops. Movement of water is not restricted. That's why this method is sometimes called wild flooding. Next we have border flooding. So in border flooding, now you can see that we have provided these levees or ridges. You can see these are provided here. So the area is divided into strips. You can see here the area is divided into these strips. One is this border here, and then this is another border here. Then you can see another border here. So the area is divided into these strips. Land is divided into number of strips separated by low levees called borders. The land area of the strip, the width varies 10 to 20 meter, length ranges 100 to 400 meter. Ridges between the borders should be sufficiently high to prevent overtopping during irrigation. The land should be perpendicular to the flow to prevent concentration of water on either side of the flow. So the water should uniformly distribute over the land. There should not be concentration on either side. Next we have check flooding. So in check flooding, you can see that further we divide the area by these connecting levees into again small plots in the form of small plots. You can see here the area is divided into small plots. This is here. And so on. So this is check flooding. It is similar to flooding method except flow is controlled by levees. Levees are constructed along contours with interval 5 to 10 meter. These levees are connected with cross levees. The confined plot area varies from 0.2 to 0.8 hectares. This method is suitable for permeable as well as less permeable soil because we control the flow. You see that in check flooding, in here or in border flooding, the water is controlled as compared to this free flooding. That's why movement of water is not restricted here. That's why it is called wild flooding. But in these methods, the flow of water is controlled. Now we further divided the land into small strips in check flooding. So that's why this can be suitable for permeable soil as well as less permeable soil. If the water seeps quickly, no problem, it can supply water to the root zone here. But if the whole land, the permeability is more, the water can seep quickly before it reaches to the other areas. So that's why this method is suitable for permeable as well as less permeable soil. Next we have basin flooding. So in basin flooding, what we do is that we have this main ditch, and through subsidiary ditches we just provide water to these small basins in which we grow these plants. So now this method is suitable for orchard trees, means the fruit trees that we grow. This is known as basin flooding. This method is a special type of check flooding and is adopted especially for orchard trees. One or more trees are placed in basin and the surface is flooded as in check method by ditch water. You can see here the water flows in main ditches and through subsidiary ditches, then we can supply water to the basin. So you can see to trees, orchard trees, this method is suitable. we have another method, that is furrow irrigation method. So in furrow irrigation method, the whole land is not flooded as we saw in the previous techniques. Rather, we have the water through this ditch here, and then in the field we make the field ditches. These are also known as furrows. So the water only moves in these furrows. It does not spread over the whole area. So these water and the furrows, they infiltrate into the root zone and provide water to the crops. So it means this method is suitable for crops that can be grown in rows. You can see here, these are known as furrows. The water is supplied only in these furrows or field ditches. You can see here. So it means that we are saving the water in this method because the whole land is not flooded as compared to the flooding methods. So furrows are small channels which carry water down the land slope between the crop rows. Water infiltrates into the soil as it moves along the slope. The crop is usually grown on the ridges or raised beds between the furrows. In flooding methods, water covers the entire surface, while in furrow irrigation method, only 1/5 to half of the land surface is wetted by water, so it results in less evaporation. So it means this is more efficient method as compared to the flooding techniques. This method of irrigation is used in the irrigation of row crops like potato, maize, sugarcane, cotton, tobacco, with furrows developed between the crop rows in the planting and cultivating processes. So this method is suitable for row crops which are grown in rows. Next we have sprinkler irrigation method. So you can see here, So as you saw in the video, so a sprinkler system, it conveys water through pipes and applies it with a minimum amount of losses. So in this method, it is more efficient. We can supply the amount of water that is required by the crops, plants. It can result in reduction of the losses that will exist in the other conventional methods. We can save more water here through this system, but of course it is more costly to provide a network of pipes that can supply or spray the water over the crops. So cost of installation and then operation and maintenance, these could be challenges to successfully operate these systems. Water is applied to the soil in the form of spray through a network of pipes and pumps. It is a kind of artificial rain. It is a costly method. It can be used for all types of soils and for widely different topographies and slopes. Because we just spray the water, so it could be independent of the topography. That's why it can be used for widely different topographies and slopes. It can advantageously be used for many crops because it fulfills the normal requirement of uniform distribution of water. So you can see that we spray the water over an area, it can uniformly supply the water to all parts of the area. Because in the flooding technique, the water can infiltrate quickly if we have more permeable soil. And as the water moves over an area, the quantity can significantly reduce. So this method has the advantage that it fulfills the normal requirement of uniform distribution of water. Suitability of this method: uniform application by artificial rain, good application efficiency 70 to 80%, dependent on wind, temperature and humidity, fairly terrain independent, but design must take terrain into account, can have a low labor content, because you see if the system is efficiently running, then it can have low labor requirements. However, more initial cost to install such system, high maintenance cost due to pumping, and can be complex to run. You can see here that in the context of Pakistan, we have not adopted this system on large scale. The reason is that the initial cost of the system, then the operation and maintenance of this system, we have to train the farmers to efficiently run this system. Types of sprinklers can be permanent, that the whole of the system is permanently fixed in that area and supplies the water, sprays the water. It can be semi-permanent. We have the main pipes that are fixed and the laterals that spray that can be removed and again brought and fixed when we apply the water. Or it can be portable, means the whole system can be moved from place to place and used for irrigation water supply. How does Saudi Arabia make use of central pivot irrigation? This is what we mean. You can see these wheels, the whole system can be moved. And it can be like this. This is central pivot, clear? And we have this whole system. It can move around this center here. And you can see here, it can sprinkle the water and it can move all around here. So this is central pivot irrigation. Of course, this is the sprinkler system. So that's why you can see that a huge circle land on which the crops are grown, and we can just simply move this sprinkler all around this center here, central pivot, clear, and supply water to the crops here. This is extensively used in the US. In Saudi Arabia, you can see here that this is the picture taken from the space. You can see here that how Saudi Arabia is utilizing this central pivot irrigation system for growing crops. This is made possible through these systems. Next method is drip irrigation method. In the drip irrigation method, you can see here that we pump the water from the source, then the water passes through the screens to remove any undesirable solids, wastes, clear, and then through a network of small pipes, the water is supplied directly to the underneath the plants. You can see here this drip irrigation method. It can be surface, it can be subsurface also. So you see a network of small pipes that directly supply water underneath the crops or plants. We can see consequently the efficiency of this method will be largest. In this method, you see that we have a network of small pipes and that directly supply the water to the plants, trees. So the whole area is not flooded. You see, even in the sprinkler system, the water is sprinkled in the form of artificial rain, but in here only the water is supplied underneath the plants. So here the efficiency is largest. We are just supplying water to the crops. This is the drip irrigation method. It is also called trickle irrigation. It consists of an extensive network of pipes of small diameter that deliver water directly to the soil near the plant. The drip nozzles, also called emitters. Here you can see we will have emitter here that will just directly supply water to the plant, are fixed on laterals at regular intervals of about 0.5 to 1 meter, discharging water at very small rates of order of 2 to 10 liters per hour. We discussed the different methods of water application on farms. So, least efficient to most efficient methods. Flood irrigation, you saw that we flood the area, we supply more water than is required by the plants. Consequently, its efficiency is less. Then we studied about the furrow irrigation, where we supply water in furrows, not the whole area is covered. So consequently, this is more efficient than the flood irrigation methods. Then we studied sprinkler irrigation, where we spray the water on the surface of land, but we can save the water. We just provide the required quantity of water that is sprayed on land. And finally, we discussed the drip irrigation, where we directly supply the water underneath the plants. That can result in saving more water. So the efficiency of drip irrigation, that is largest. But in Pakistan, you see that we are using conventional methods. The reasons given are that we have more water available to us. And if we are using the methods like sprinkler irrigation and drip irrigation, so these are costly methods. Costly to install these systems for irrigation water application, and then the operation and maintenance of these systems. So these are the reasons why we do not use the latest technology of water application that can result in saving the water, and we can grow more food. Pakistan can become food self-sufficient, and we can earn money with that through exports. So we are using the conventional methods of irrigation, and this is the reason that Pakistan has the largest continuous irrigation system in the world, but the crop yield is lowest in the world. Now, key points for best irrigation method: uniform water infiltration. Water should infiltrate into the soil uniformly over the area. Deliver water to the root zone, because the plants will use the water for growth. So all the methods should be able to deliver the water to the root zone effectively. With high efficiency, just like we discussed the efficiency of the different methods. With lowest operative cost, the method of application of water to the crops, that should be lowest. With lowest cost per acre and per metric ton produced. So these are the key points for the best irrigation method.